When we talk of real infinities, we're talking about a quantity larger than any number. No matter what number you have in mind, infinity is larger. There's a nice way to write large numbers. You can write the number 1,000 as 10 to the power 3, meaning a 1 followed by 3 zeros. Or a million is written as 10 to the power 6, meaning a 1 followed by 6 zeros. There's no largest number. If anybody gives you a candidate largest number, you can always add the number 1 to it. But there certainly are very big numbers. The American mathematician Edward Kasner once asked his young nephew to invent a name for an extremely large number, 10 to the power 100, which I can't write out all the zeros in this page for because there isn't room on the page. The boy called it a googol. If you think a googol is large, consider a googolplex. It's 10 to the power of a googol. That is a 1 followed not by 100 zeros, but by a googol zeros. Now, by comparison with these enormous numbers, the total number of atoms in that apple pie is only about 10 to the 26th, tiny compared to a googol, and of course much, much less than a googolplex. The total number of elementary particles, protons, neutrons, and electrons in the accessible universe is of the order of 10 to the 80th, a 1 followed by 80 zeros, still much, much less than a googol, and vastly less than a googolplex. And yet, these numbers, the googol and the googolplex, do not approach, they come nowhere near infinity. In fact, a googolplex is precisely as far from infinity as is the number 1. We started to write out a googolplex, but it wasn't easy.
It's a very big number. Writing out a googolplex is a spectacularly futile exercise. A piece of paper large enough to contain all the zeros in a googolplex couldn't be stuffed into the known universe.
Fortunately, there's a much simpler and more concise way to write a googolplex. Like this. And infinity can be represented like this.